Okay, welcome geometry students. Today we're going to do a lesson that is on writing equations of lines. This is our unit on coordinate geometry, and this is merging things that we've done in perhaps in Algebra 1 as well as what we're learning in our geometry class. We've had a previous lesson on the point slope form of a line. So when I give you some point, here I'm going to write h comma k as the point that I'm going to give you, and the slope is m. We learned that the point slope form of a line is y minus the k, the y value of the point given, and it's going to equal the slope times x minus the h that was given. This is derived from the equation of the slope, which is if we divided this by x minus h, we would have the change in y being divided by the change in x, which is slope. But so this is maybe a newer form of a line, because in Algebra 1, you most likely used a different form of a line, which was the slope-intercept form of a line. And in this handout, I want us to all use our simplification to take up an equation that's in the point-slope form of a line and rewrite it in the slope-intercept form, which, to recall, is y equals mx plus b, meaning you solve for y. And here you've got the slope, and the b stands for the y-intercept. So the first problem we're going to do together, problem number 1, we have a point, we have a slope, we're going to use that format. So it says y minus the y that is given, which is 1, is going to equal the slope 2 times x minus the x that was given, which is 4. So we've written it in point slope form, but we need to solve for y to write it in the slope intercept form. We distribute the 2, we have y minus 1 equals 2x minus 8. And now we're going to add 1 to both sides to finish solving for y, and we end up with y equals 2x minus 7. And so here it is in slope-intercept form of a line. We like this format for a line because for this, it makes it really easy that if we were going to graph this line, we would, on our axes, where we have to have an x and a y axis, we would go down to -7. So if this was -7 on our y-axis, the slope is 2, so we would go up 2 and over 1, go up 2 and over 1, and up 2 and over 1, and then connecting those, we would have the graph of the line. So the slope-intercept form of a line is really nice for graphing. We can do one more of these together. We're going to do problem number 3 together. And in problem number 3, we're going to have, here's our point, and here's our slope. So we have y minus the y that was given, which is 0, is equal to the slope, 2/3, times x minus the x that was given. What was given was -6. We're going to subtract a negative, which turns it into addition. So we subtracted a negative. I made the 2 slashes and created an addition symbol. We're going to simplify and solve for y. So we're going to be distributing that 2x, well, the 2/3. So 2/3 times x is going to be 2/3 x. 2/3 times 6, 3 cancels with 6 to give you 2. 2 times 2 is 4. So that's distributing the 2/3. On the other side, I've got y minus 0, which is simply y, and you're done with that problem. That was all there was to it, since we didn't have to subtract or add anything to the left-hand side. We have y all by itself. So we've got it in slope-intercept form. You're going to do problems 2 and 4 on your own. I'll have answers posted so you can check your work. In practice set 2, well, we don't have the slope. We have 2 points, but recall that your slope is the change in your y's, and so you would subtract your y's, and typically the formula is written y sub 2 minus y sub 1, and then we're going to divide that by the change in our x's, x sub 2 minus x sub 1. I've shown you that an easier way to write that also is to say the change in your y divided by the change in your x. You just have to make sure that when you're finding these changes, you're starting with the same point every time, which is what this formula helps to remind you, that you can't switch, subtract -1 minus 7 and then do -3. You got to stay starting with 1. I like to start with the point on the right. So my slope is going to be, I'm going to start with my y's, -1 minus the 7 over 1 minus negative 3. 1 minus negative 3, which turns into addition. So we've got negative 8 over positive 2, which gives us a slope of negative, over 4. I'm sorry, over 4. I subtracted them. Negative 8 over 4, which gives us a slope of negative 2. So there is our slope. Since we have our slope, we get to pick a point, and it doesn't make any difference which point we use. I'm going to use this point because it just has smaller numbers. This seems like, the smaller the number, the easier it is to simplify. Y minus negative 1, which means y minus negative 1 becomes an addition problem, equals my slope, negative 2 times x minus my x is 1. And I'm going to distribute that negative 2 and have y plus 1 equals negative 2x. Negative times a negative is a positive. 2 times 1 is 2. To finish up solving for y, we subtract 1 from both sides, and we end up with y equals negative 2x plus 1. And this is the equation of the line in slope-intercept form. You're going to do problem number 2 and 3 and 4. Actually, not problem 2. Problem 6, 7, and 8. And each time what you're going to do is you're going to find their slope and then use either one of the points. So it doesn't make any difference which one. So in this problem, which point would I rather use? It really doesn't make any difference, but you need to find the slope and then pick one of those points. The same thing with both of these problems. Now let's look at the next group of problems. And this is writing equations of parallel lines. And recall that parallel lines means they have the same slope. So we just need to find the slope of each of the given equations and then use that slope with the point that's given. I'm going to have you do problems 9 and 10, and I'm going to skip down here, and this is the problem I'm going to work on right now. I need to find the slope. I'm just putting a line here to do my work over here. I need to find the slope of this line. One method would be to solve for y. So let's do that one first. I'm going to subtract 6x from both sides. When I do that, I end up with 5x equals negative 6x minus 10. But I'm sorry, it's 5y, not 5x, 5y, minus equals negative 6x minus 10. We're going to divide everything by 5. And we end up with y equals negative 6/5 x minus 2. I don't even really care a whole lot about what the y-intercept is, but this is my slope. So I know that for this equation, the slope is negative 6/5 because I want the same slope. Now, before we move on and finish this problem up, I want to look at another way to have found that slope. You might have had this in Algebra 1, but equations of lines can be written in many different formats. We're learning now new ones, the point slope format. You knew the slope intercept format. There's also a format called standard form, which is ax plus by equals some constant. And when an equation is written in this format, which this one was, your slope is always, because you would have subtracted ax and then divided by b, it's always the opposite of a divided by b. And so if we looked here right away, we said, oh, the opposite of 6 is negative 6 divided by 5. And we ended up with the same thing. So this is just another way to find slope when given in standard form. So you can either solve for y like we did here, or you could remember this formula. It's all about how many formulas do you want to memorize. So now that we have the slope and we have this point, we're going to use the slope and the point to write the equation of the line. Y minus the 9 is equal to the slope, negative 6/5, times x minus negative 10, which gives us x plus 10. We're going to distribute that negative 6/5, and we're going to get negative 6/5 x. Negative 6/5 times 10, well, the 5 and the 10, the 5 cancels with the 10 to leave 2. 2 times negative 6 is negative 12. So we're going to have a negative 12 here. And we have y minus 9 on this side. We're going to finish this up by solving for y. So we're going to add 9 to both sides. And that's going to give us the equation y equals negative 6/5 minus 3. And this, sorry, just kind of squeezed in rather tight right there. That's the equation of a line that is parallel to the one that was given, but goes through this point. This point is not on that line. Okay. All right. You're going to do the other two problems by finding their slope, because remember the slopes are equal, and using the point and writing the equation of those lines. The next set of problems has to do with perpendicular lines. And for those ones, you need to find, remember perpendicular lines are if M is, you've got your, you've got y over x, whatever that is, okay? You're changing your y over x, you got this. Then the perpendicular slope is going to be the negative of the x over the y of the given equation. So here is, and I shouldn't use x and y, I'm just trying to say that it's a rise over run, and then you flip it and make it, you flip it and do the opposite of it. So this one has a slope of 3/4. I'm going to write it like this. I'm going to start this problem for you. The slope is 3/4, which means the perpendicular slope is going to be the opposite. Since this was a positive, it's going to be negative. Instead of 3/4, it's going to be 4/3. So this is the slope you're going to use along with that point. And I'm going to have you finish that problem up with your homework. I'm going to switch over here to this problem, number 14. You're going to do problem 13 as well. You need to find the slope. So you'll find the slope of this line here. And then so you'll have your slope, and you'll have it. And then you need to find the perpendicular slope, and you'll find that and use that with that point. For number 14, here we have this line. And right away I'm going to say, okay, the slope. I'm going to use that method that I was showing you before. If this is ax plus by equals c, the slope of this line is the opposite of a. So instead of 5, it's going to be negative 5 divided by the b, which here in this case is 3. So that's my slope, which means my perpendicular slope is going to be the opposite. Instead of negative 5, it's going to be positive 5/3, except not 5/3. We're going to flip it, and we'll get 3/5. So this is the slope that I'm going to use along with this point. So I've got y minus 1 equals my perpendicular slope, 3/5, times x minus, and this is a negative 5, so that becomes positive, subtracting a negative. We're going to distribute that 3/5, and we're going to get y minus 1 equals 3/5 x. 3/5 times 5, the 5's cancel, and we end up with 3. We're going to add 1 to both sides, and we end up with y equals 3/5 x plus 4. And that is an equation of a line that is perpendicular to the given one, but goes through the point negative 5, 1. The last part of our working together is doing a problem where we're going to find the equation of a perpendicular bisector. Now the perpendicular bisector cuts something in half, and so to cut in half would mean we need to find the midpoint. Okay, and if we were to find the midpoint of AB, then we'll be able to find, we'll have a point, and then we can find the slope of AB and find the perpendicular for that. And that's exactly what we're going to do. So first of all, step number 1 is to find the midpoint. The midpoint is going to be where you take your x's, 5 and negative 1, and you're going to add them. 5 plus negative 1, which is 5 minus 1. And then you're going to divide it by 2. And that's going to give you the halfway point. And then we're going to take our y's, negative 2 and 4, and we're going to add those, negative 2 plus 4, and divide those by 2. This is going to give me my midpoint. So 5 minus 1 is 4. 4 divided by 2 is 2. So we have 2. Negative 2 plus 4 is 2. 2 divided by 2 is 1. So we have our point. Okay, this is our point. Now we need to find our slope. Our slope for this, we're going to subtract our y's, negative 2 minus 4, negative 2 minus 4, and subtract our x's, 5 minus negative 1. 5 minus negative 1. We end up with negative 6 over positive 6, which gives us a slope of negative 1. This is the slope. We don't want the slope, we want the perpendicular slope. So the perpendicular slope is the opposite. Instead of negative 1, it's going to be positive, and when you flip 1, you still get 1. So now we have our slope and we have a point. We need to write the equation of a line. I've kind of run out of room. I'm going to write it over here. So I've got y minus r1 equals our slope times x minus 2. Distributing the 1 doesn't make any, we're going to just add 1 to both sides, and we're going to get y equals x minus 1. And this is the equation right here. This is the equation of the perpendicular bisector. So we're going to graph it now to see if this works out. We start by graphing A and B. A is negative 1, 4, so I go over negative 1 and up 1, 2, 3, 4, and we put a dot right here. And that is the point A. Then we have to go 5, negative 2, so we're going to count over 1, 2, 3, 4, 5, and down 2, and put our dot right here. And this is B. We need to carefully, and so you should try to find a straight edge, a ruler, something that's firm that you can use to do your lines. And so I'm going to connect this. This is not a line, this is a segment, so it has a beginning and an end. It starts at A and goes to B, and that's the end of it. And now that we have sketched the segment AB, we're going to sketch this line right here. Oh, that's a slope, sorry. This line right here, where it says go to negative 1. So on my graph paper, I'm going to go down to negative 1, and I'm going to put a dot. And it says the slope is, I could have just graphed this point here to positive 2, positive 1, and we would have seen it, but I graphed for my y-intercept, and I'm going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. I can see that I have a series of points, and I'm going to connect them. And this is a line. It is not a segment, it is a line. And we can examine this, what we just graphed, and we should notice that this segment was cut in half, and it is in fact perpendicular. Their slopes are opposite reciprocals of one another. So this is what this problem number 15 it looks like. I'm leaving number 16 for you to do for your homework. And again, I will post the answers on the website.